We are here to explain on how to find the x-intercept and y-intercept of the function. So given the function y equal to x cubed minus 6x squared plus 5, to find the y-intercept, we must let x equal to 0. To substitute x equal to 0 into the function, and we will get y equal to 5. And then to find the x-intercept, we must let y equal to 0. That is x cubed minus 6x squared plus 5 equal to 0. And then we factorize the function, we will get x equal to 1 and x squared equal to negative 5. Since x squared cannot be equal to negative 5 because x cannot be equal to square root negative 5, so we rejected this answer. Hence, the y-intercept of the function is y equal to 5 and the x-intercept of the function is x equal to 1. Thank you.
For the external point, we have to do the second derivative from the first derivative just now. Okay, the first derivative is 3x squared minus 12x. So when we do the second derivative, we will get the 6x minus 12. So when x is equal to 0, we substitute the second derivative, we will get y is equal to negative 12, where the y value is less than 0. So it is the maximum point. When x is equal to 4, when we substitute to the second derivative, we will get the value of y, which is y is equal to 12 and more than 0. When more than 0, we will get the minimum point. So the conclusion is 0, 5 is the maximum point, while 4, negative 27 is a minimum point. Thank you. Okay, for the second step is we have to find the minimum and the maximum point. From the equation, x cubed minus 6x squared plus 5. So to find the minimum and the maximum point, we have to do the turning point. Turning point is when dy dx is equal to 0. Okay, we have to differentiate the equation first. X cubed minus 6x squared plus 5. If we differentiate, we will get 3x squared minus 12x. Understand?
Yeah.
Okay. So dy dx, when turning point is when dy dx is equal to 0, right? So we from the equation 3x squared minus 12x is equal to 0. Then we differentiate it. Then we factorize it. So we get the x in bracket 3x minus 12 is equal to 0. So we have x is equal to 0, and another one x is equal to 4. So when x is equal to 0, y is equal to, we have to substitute. No? Substitute. So when x is equal to 0, y is equal to 5, while when x is equal to 4, y is equal to negative 27. So the turning points are 0, 5 and 4, negative 27.
Hi, now I want to tell you how to find the point of inflection. So we need to use second derivative. So this second derivative must be equal to 0. Then we take the function 6x minus 12 equal to 0. Then we will get x equal to 2. So when x equal to 2, we need to substitute 2 into the main function. So main function is x power of 3 minus 6 x power of 2 plus 5. So we substitute 2 in x. So we will get negative 11. So now we already get the inflection point, which is 2 and negative 11. Okay, so now I want to explain how to find the increasing interval for the graph. So we need to use first derivative, which is dy dx more than 0. So we take the function, which is 3x power of 2 minus 12x more than 0. So we will get x more than 0 or x more than 4. So the conclusion is the function is increasing for x less than 0 or x more than 4. Meanwhile, I want to find the decreasing interval for the graph too. So we also use dy per dx, but this is less than 0. So we take the same function, which is 3x power of 2 minus 12x less than 0. So to find the x, we will get x less than 0 or x less than 4. So the function is decreasing for x 0 less than x and less than 4.
Okay, for find the concave upward, we must find the second derivative. Firstly, concave upward, second derivative more than 0. So the second derivative is 6x minus 12 more than 0, and we get x more than 2. So in the graph, we can see concave upward, and more than 2 is concave upward. Okay, the function is concave upward at x more than 2. So for concave downward, second derivative must be less than 0. Okay, so second derivative is 6x minus 12 less than 0. So we get x less than 2. So in the graph, less than 2 is concave downward. Okay, so function is concave downward at x less than 2. Thank you.